Hello, my hosts, and welcome to another programming stream. Today we are continuing with Project Tween, which is our animation software. In particular, we're going to be working on the code that renders primitives into shapes. I'll show you what I mean in a split second. So here we are. So what we do is we have all of these structures like end-on circles, closed paths, outlined lines, backgrounds, and some basic Boolean operations. And I just realized I should add, probably in a commented out section, transform, which will take shapes and 3 vectors for scale, rotation, and what's the other one? Scale, rotation, and translation. That's a to do. There we go. And we've got the code for the basics here. What we need is code for creating these things. Now, these should not actually be paths or points. I have realized that this was a mistake. Should represent a path through space-time. So type, which converts from just a function that moves something from float to a point. Actually, make that to a point. Now, just if we go like that, and we go tell that to render. Actually, does that compile? Oh, compiles. That was remarkable. So now we go to here. Oh, we don't take a float. That is completely wrong. We take a thing called context. It's a data context, which at the moment is going to be like that, with time that it's afloat. Sorry, float time. No, it's I think that's how record syntax works. Let's just check that. All right. Let's check the manual. Streaming? Yep, cool. Haskall record syntax. Named fields, blah, 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 named fields. Configuration. Okay. Why? Oh, it's that thing. Awesome. Right. Okay. The path is that to that. So render point. How do we use combine? That's saying that this point is at that value at that point in time. But we are traveling through thing, and we want to linearly interpolate between those points. Otherwise, all right. So what is the X, Y, and Z values there? Their values, which are also that. Okay. Path. So point has to actually be also a type. Move this back. Point is text to a pair of floats. Float, float. that. Perfectly fine. This will be value, which is st value to excuse me, value. Copy that. We set that to undefined. Hi, Amato. How are you going today? I hope you are going well. I'm still working on programming this. Right. Yeah, fine. You? Yep, I'm good as well. So this returns a point, which takes from context to a pair of floats. Not sure what we're going to do with the T there. Have I done my dinner? Actually, we are actually in the morning here, so it will be coming up on lunchtime rather than dinner time. But I have eaten well. So my brain is confused, so many words. That's okay. The trick is you just take some of the words one at a time. And that's how you deal with it. So we got the path concept, which takes a context value. So let's what we're going to be returning. So slash text. And that returns path, and a path takes returns a point, and the point returns context. Okay. That tells me that that shouldn't have a T there. That should just take two values. That's going to cause a whole lot of errors, but that's fine. Context. And you will return a pair of floats after you take... I'm just... Actually, should that... That's wrong. That should just be point like that, and it should be float, float. So this is our representation of an X and a Y coordinate. And it should be data, not date. There. Over here, so it goes like that. We say point render value X the value Y. So what this will do, if we are given the combine point operative, it'll render the value for X and render the value for Y. Oops. But it'll have to do that with context. So we'll have to say render value context like that. And that st value to value. That will come out as floats. Let's try that. What does the... All right. Render value to blah, blah, blah. Vector type context to float to float. All right. Good point. Context to float. Yep. 78. Yeah. 73. Get rid of all of these. All right. That's fine. And we're going to have a... like that. All right. Oh, yeah, okay, that's doing what I wanted to do. Sorry. Ah. Patterns, not param. We can do that with... All right. It's a little bit confusing. Render point there. Render point st. Path. Whoops, that's wrong. So param. Ram. So that's the P value. This will be a path. The context. There we go. Like that. It returns a path. Oh yeah, the path. Okay. So I'm going to return a point. On that path at that point in time, which is kind of meta. I'm going to have to be right back. Let's hit myself on that be right back button. And we are back. So, moving through this, I've realised how we work this one out. We have to render this path with a, I don't know, this path value is this path here. So we first render that into Bezier curves using our so this is going to have to be a closed path where it says this should never happen, will happen. Okay. This is used when we are rendering an abstract path. Sorry if I'm not explaining everything. So that value that has a value, doesn't it? End. Path, scale. End. Okay, so it's end point. Dual. So, as well as loop. Got end, which is another path for abstract paths. All right. Where's the bit that I did? End, render, point, and door. Excellent. So, the way we do this is we take P, so P is a value. So, the value P. I'm going to create a new context for it. Update value in a record Haskall. Change to record update to right. context time is float. Render value context, that gives me a float. And then from that float, I put it into there. So I know this sounds a bit weird. So it goes time equals context like that. And we render point with that new context for that part. Oh, hold on. That's missing something. I've got to render the path as well, which we just use render. What am I? That doesn't look right. Render path with st path. Okay. Oh. Good point. So that's supposed to be render closed path. Copy that. Render closed path. With a empty biome. Gonna have to put a thing like that for the time being. And that gives us a shape. All right. And our hole is there. That should be ambiguous. Oh. More on scope. Oh, render closed path. Node 4. Okay. That makes sense. What's the simplest node 4 that we can have here? Const 4. Okay. Is it BT for biome tree? Yep. So I'm just going to actually we can do it here. Just have a handy constant, which is full transparent. Okay. Trans BG, which will export from here. Trans BG, which is const 4. And we use abstract color. Abstract color, okay. Import lib, which is my anything's color 0, 0, 0, 0. Const 4. Then we go back to here. Where are we? Consistent form of Bezier curves. We say trans BG. This does not feel right, but cannot. Oh, hold on. That one's ST shapes? Oh, yeah. Actual type shape. Oh, this will have to render into a... This will have to render into a camera value. Oh, that's going to be ugly. Okay, this thing's got to be left. Hold on. Does it have to? All right. This is me just working things out as I go through it. So this should give... Hello, Mamutator. What the intent of param is, let's just write that out. Gives the value of a point on the path at time equal to value gives the point on a path at path that path would be at the value time. So in order for that to work, we have to actually have the code that renders the Bezier curves into coordinate values, which we kind of don't have at the moment, so we can't do param. So we're going to do this one at the moment. Undefined. All right. Hold on. We get that separate. We can define it in separate. All right. I'm just going through this all. I think I'm going to have to work out some okay, when we do separate X, okay. This isn't actually so. This is me just thinking through things. Let sub path equal render close path there. And all right. Value takes a value takes a path. Okay. So X equals render value render value all right. Let context P equals the new time with that set up like that. we say x equals render value context P. There we go. Path up. St dot value separate x path. We do the y the same way. In point x, y. I think that does what it... Oh. St separate x. Did I get the context wrong? Yep, I did. There we go. There's another one done. As many as of these we can reduce to having the number of these we can reduce into having... Looks like my OBS is disconnected. Oh, and we should be back. Something weird happened with our stream, but we are back. So render point, next one is grade, which gives us a gradient between 2 points. Grade point A and point B. Oh, we can say A and B. B. So context. Right. We can use the we just use rise over run? I guess so, because it is between 2 points. So we can use yeah, that's how we're gonna have to do it. All right. So AX equals the value P separate X A, hold on. These are both points. So it's not that. I'll separate A, okay. So the point A, do I have that? Functionality here. Yep, because I use it. So we render point A. I'm going to call that point A. I think it's going to be reusing it. Point A equals render point A, which makes it a path. So we should call it path A. Hold on. Context to a point. Point float. Okay. My brain is starting to overheat. The time's 12:30. Oh, cool. A with the context. Path B with the point B context. AX render value A right X separate X path A to oh, I'd have to flip that. Okay. So, and value separate X path A context AY equals same thing. U Separate Y context. There we go. BX, BY. Oh, realised I've got to go let. In. Hold on. Is this supposed to give the gradient? Which is a 2D figure. Sorry, it's a single figure. This is not supposed to be in this tree. Okay. You get moved over to here. We don't have to do that one at this point in time. Right. ST normal. So, where I got that, that should be actually tangent to the point. Actually, we can't have tangents to a point. We've got to have tangents to a path. Gives a line tangent to a path. Cool. 1 to 8. 1 to 8. 1 to 8. Like that. Let's fix that up. Have I spelled it differently in two spots? Tangent. There we go. Ah, right. Gonna have to think about that as well. So that actually is that is actually diff. That is point. That's ST sub, so that's subtracting one point from another point. All right. Good. All right. path. Let's move that down so we can tackle it later. Oh. Let's move these up. So they're going to be easier, I suspect. Scale. Oh. How do we redo? Edit. And scale. There. Right. Huh. Yeah. Render point. Param. Okay, add. Text. That. Render for blah, context float. I don't have to do that. I have realized that is foolish. X, comma, the render value is render point path is that to there. Okay. So if I say XP like that, all I got to do is say point path context P. Save that like that. And I've got screwed up indentation, but that's fine. We don't even need that. Go. Shift the context and feed it into render path. Render point, sorry. And oops. Comment that out. First argument. Param. Oh. point. I did have to do that. All right. That was me thinking too far ahead and so st add A and B so we're adding those 2 points together. So context x A x so A x sub A x so y sub A equals and point A given a context. Oops. Let that there. XB, YB. Cool. Render point. B given a context. That's fine. In did I call that point? I'm pretty sure I call that point. Yeah. So we go point A, comma B, point there, should follow conventions we've set up. In point XA plus XB, comma YA plus YB. Done. Oh, we don't need the commas there. Actual type float. What? Point is float. Oh. Point A plus B like that. What? 172. I thought we'd already done that. Oh. Did I go too far? Should that be... Yeah, point. Y. All right. And now we got sub. That's easy enough. Copy you. Sub minus B A. Right. Scale. Another easy one. Scale, and so that's the vector. So that's vector A, and that's scale. Render A like that. XA times scale. And we're going to have to render the S equals render value scale context X times S YA times S. These are nice and easy. In. Okay. Parse error on blah, blah, blah. What am I missing? Let's move those over to some nicely lined up. Ah, it was all just a matter of getting things nicely lined up. Okay. Reverse. Is that just simply... like that? Reverse A. And a point like that. Point X times minus 1. Y times minus 1. Oh, forgot the in. Oh, and weirdness. A minus 1. think that will mitigate it. Yep. And then we've got the normal and the tangent of a path. All right. How to calculate normal of a 2D vector. But you have a 2D line. Got to give some thought of, so that is another one. It's the normal of a path. Okay. These ones I can't, probably need to do a little bit of research to work out how to do those properly. Or do I? Yes, I do. But I think we've made good progress on that bit. All right. Yeah, the real meat and potatoes is going to be when we're going to separate path and that. Okay. But I think we will take a break for lunch, and I'll either do another stream where we continue to program, or more likely I will get onto some editing. So thank you everybody for joining me in this stream. Let's go back to my main room. Thank you everybody for joining me with this programming stream. Tomorrow we'll have a more orthodox Vtuber experience with, let's have a look at our schedule. Just gonna double check. Factorio, cool. So I will be doing another set of problem solvings in Factorio. So I hope to see you there. Thank you everybody for the stream, and I'll see you later. Goodbye.